Hi, everyone. I'm Brian Bohman. I feel a little bit like the odd duck out in this department sometimes because I'm a water resources student, but I'm housed here with Dave and Carl. My previous background was at St. John's University. I was the liberal arts school in Minnesota, for those of you who aren't familiar with it. I studied natural science. I actually have a BA in natural science. But I got interested in water quality issues and how they relate to agriculture. And so here as a recently transitioning or currently transitioning from a master's to a PhD project, I study hydrology and water quality, nutrient and irrigation management, precision agriculture. And my project has two major components, which I'll talk about. Potato field study, where we're looking at irrigation and nitrogen, and then also a simulation modeling study using the model EPIC. So what drives me? I included this part, the strengths part, and if any of you have done the Strengths Finder assessment before, this list of 5 things, when I did the Strengths Finder assessment, it's actually what kind of steered me into going into a graduate program. I looked at this list and I was like, this wasn't on my radar, but I think this is something that will fit me well. And I really enjoy the work I do here as a graduate student. So my academic interests are reducing the impact of irrigated agriculture on water resources, increasing input efficiencies and profitability for irrigated crop production. I'm becoming more and more interested in advancing the incorporation of AI technologies into decision-making, artificial intelligence, machine learning, those sorts of things. And I'm also becoming more and more interested in water resources, agriculture, and conservation policy, really focusing on doing good science, but then how do we turn that into good decision-making and making sure that changes actually happen that will benefit society. So my goals include developing an in-season decision support tool for potato production. That would be something that you could customize for a producer in a particular area and say, today you should apply nitrogen or not, you should apply irrigation or not. And that would be a big step forward in the available technologies. Providing localized guidance and cost-effective best management practices. So being able to go to certain regions of the state where there's concerns about water quality issues due to certain crop production practices, saying this might be the most cost-effective thing to do in this area. And one of the last goal I have on this list is to improve communication, understanding of true problems. And this is something else I've recently come to. And when I say true problems, I really mean trying to break through what our assumptions of the problems are and really dive deep into what the causes of the problems we're tackling. So really a critical assessment and really trying to dive deep, if that makes any sense. So my field study, potatoes. Some of these pictures might look similar to Emerson's because our plots are right next to each other. So a couple of images I put up. This is some of our plots at the lovely Becker Sand Plains Research Farm. We're doing some remote sensing work, both with the crop scan. It's a ground-based multispectral radiometer, so we're taking, that's how we're able to assess nutrient nitrogen decisions in season. We're also doing UAV images with the help of Centec. They're flying UAVs for us. We have 6 different nitrogen treatments. Some of them are polymer-coated ureas. Some of them are just regular ureas. And then we also have a variable rate nitrogen treatment that we're assessing as well. We're looking at the irrigation management component, not only from the scheduling of irrigation, but how do you know how much moisture is in the soil? And that's been one of my biggest challenges. And that's just a lovely picture of potatoes. The last thing I want to talk about is the simulation modeling part of my study. This is something that's just beginning, but I see it as a way to tie together a lot of the work that has been done through Carl's lab with potatoes. There are potentially 27 study years of data available that could be assimilated into a single simulation model. And so by designing a system to go through these studies and calibrate the model, rather than just working with one study, we can work with all of these studies to potentially get a better assessment of the accuracy of this model. I listed some of the things that we're looking at in calibrating the model. I don't have many results to present because I feel in the upswing, but I'm happy to give this presentation and take any questions you may have. Thanks.
how are you going to use 27 different studies in putting the model together?
It's really a logistical problem rather than a technical one. So most of the methodology has been similar over all of these studies. There are some small differences, but by focusing on the key data that's in common, like yield, soil nitrogen, nitrogen uptake in biomass, those are key factors to calibrate the crop growth that are consistent across all of those, and the methodology and the people working through this, and it's all been at the same site too. So a lot of those barriers of stitching things together kind of go away because they're all in the same mold. You just get the variability of climate and then some of the different management practices too.
So you're mostly interested in the yield part.
The yield part is I think one of the best ways to calibrate the model. Some of the other environmental, some of the nutrient use efficiency is useful, but the nitrogen leaching perhaps might be more difficult to calibrate the model on. But if we rely on strong yield, is something we know with a high degree of certainty. So it's easier to calibrate the model to that and then draw inferences from what the model is saying about the environmental benefits.
Okay. Brian, what models did you consider using in nitrogen?
So EPIC was chosen for me, but some of the other models that were considered were DSAT, or I think NLEAF was another one that was in the proposal. The strengths of EPIC are that it looks at this homogeneous area, so we're able to look at each plot as a homogeneous unit. It's got a good hydrology routine in it, and it gives us the outputs we need, like the biomass, the nutrient components, and it's pretty well supported too from a community standpoint. Apex kind of overshadows EPIC because Apex works in this watershed scale, but for our interest in just this plot scale research, and then you can piece together a bunch of EPIC models to tell you about a larger area. So I hope that answers your question.
You have a question for Brian?